So fourth unit is embedded networking. So under that unit, you are going to cover the introduction, CAN bus, I2C, GSM, GPRS, Zigbee technology. Okay. So these are the technology you are going to cover in the networking. So first, we are going to see about the I2C bus, which will be coming under the serial bus communication protocol. So what is serial bus communication? Serial communication. What is serial communication? So in serial communication, you'll be transferring the data or receiving the data in bit by bit manner. Okay. So at a time, you will be receiving only one bit. Okay. So serially, it will be received or transferred. So under the serial bus communication, first topic is I square C. What is I square? Inter inter IC connect. That is I square C. Inter IC connect. Okay. So assume that there are number of device circuit in a number of processes in a plant. One IC each for measuring temperature and pressure. So you're going to assume that you're having number of device circuit in a plant. Okay. So in that one of the IC will be measuring your temperature and pressure value. So these ICs mutually network through a common synchronous serial bus. So I square C, that is interconnect IC connect bus, is a popular bus for this circuit. There are three ICs I square C bus standard. First one is industrial 100 kilobit per second I square C, and then 100 kilobit per second SM I square C, and 400 kilobit per second I square C. So the I square C was originally developed at Philips Semiconductor. So where you will be applying this I square C means where the device system which has a number of device circuit. So among the device circuit, that is ICs, which is placed in a implemented in a plant or system. Okay. Among the IC you have to communicate. Okay. So to for the communication purpose, you are going to use the I square network. Okay, in IC connect. So in between the IC, it will be communicating serially. Okay, this is said to be I square C bus. So three types இருக்கு. அதில் வந்து ஒன்று பார்த்தீங்கன்னா industrial SM and then 400 kilobit per second I square C. So this will be indicating that 100 kilobit per second, 400 kilobit per second will be indicating the speed of the communication. Okay. The I2C bus has two lines that carry its signal. So one line is for clock signal and another one is for bidirectional data. So two line is used in the I2C bus. So one line is for clock signal and another one is for transferring your information data. Okay, in both the direction you can send as well as receive in the same line. So there is a protocol for I2C bus. This is shown in the figure. In the figure, in the coming figure, I will show it. Then I2C bus um, uh, signals during a transfer of a byte. When using I square bus is seen in diagram. So each device has have an address using which the data transfer takes place. The master can address 127 other slaves at an instant. So master device can able to address the 127 slaves. Okay, in a minute or in a second. Okay, at a instant it can able to communicate with 127 slaves. Okay, the master device can able to communicate the slave device 127. It has a processing element functioning as a bus controller or a microcontroller with I2C bus interface circuit. So here the processing element which will be functioning as a bus controller. Otherwise, the microcontroller with this communication bus, I2C bus, can interface any other circuit, any external circuit also. Each slave can also optionally have an I2C bus controller and processing element. அதே மாதிரி பார்த்தீங்கன்னா slave device will be having the I2C bus controller and other processing element. Okay, so master also will have bus controller and processing element. அதே மாதிரி slave device will be having I2C bus controller as well as processing element. Okay, so slave and master are same device, same pick microcontroller only. Okay, you'll be having more microcontroller device. In that one microcontroller device will be acting as a master. The remaining microcontroller device will be acting as a slave. Okay, so microcontroller device ன்னு சொல்றதுனால you don't think that is a big system. Okay, so microcontroller deviceங்கிறது பிக் மைக்ரோகண்ட்ரோலர்ங்கிறது ஒரு ஐசி தான், சிங்கிள் ஐசி. Okay, I'm speaking about the IC only, microcontroller IC. It is available in the IC itself. So a number of master can also connect to the bus. So you can use more than one number of master for connecting with the I2C bus. However, at any instant there can be only one master, which is one that initiates a data transfer on serial data line and which transmit the serial clock line pulse. That means you may have more number of microcontroller device. So among the more microcontroller device, any of the device will only will be acting as a master. Okay, at a instant. So இப்போ the embedded IC microcontroller IC number 1 will be acting as a master device means இன்னொரு இன்ஸ்டன்ட்ல தான் இன்னொரு டிவைஸ் வந்து ஆக்ட் ஆகும். ஓகே, ஒரு இன்ஸ்டன்ட்ல ஒன் ஒன்லி வில் பி ஆக்டிங் அஸ் எ master device, the remaining will be slave. Okay, so அப்ப அது அதுல அந்த டைம்ல மட்டும்தான் that can be able to transfer the data in the two lines. One is for clock signal and another one is for transferring the information, okay, or data. So from the master or slave, a data frame has field beginning from start bit as per table. So either you are going to use as a master or slave for transferring the data. You have some data frames, okay, which will be starting with the start bit. This is shown, the format of the bit is shown in figure. See here, see in the table. So first field of first bit, it is a start bit similar to the one in a UART. UART is nothing but universal asynchronous receiver transmitter. So first bit will be your start bit. Okay, then second field of 7 bit. That means next after start bit you will be having 7 bits, which will be called as the address field. So where to send the data, that address will be provided in the next 7 bits. Okay, in the format, frame format. It defines the slave address being sent the data frame by the master. So master only going to transfer the data. So where it going to send? So it is communicated among the ICs only. So among the ICs na microcontroller IC only. So the one IC going to be the sending data IC going to be act as a master, means the remaining device, that is microcontroller IC, will be acting as a slave. ஸோ அந்த ஸ்லேவ் எந்த ஸ்லேவுக்கு அனுப்புறங்கிற அட்ரஸ் வந்து நெக்ஸ்ட் 7 பிட்ல இருக்கும். தென் தேர்ட் ஃபீல்ட் இஸ் கண்ட்ரோல் பிட், தட் இஸ் ஒன்லி 1 பிட். ஓகே, ஸோ ஆஃப்டர் த 8 பிட்ஸ், ஃபர்ஸ்ட் பிட் ஸ்டார்ட் பிட், நெக்ஸ்ட் 7 பிட் இஸ் ஃபார் த அட்ரஸ், தென் 9th bit is for what we are going to do, what process we are going to take, whether you are going to read or write. Okay, read means you will be reading the data in the slave device. That means you are receiving the data. write means you will be sending the data, otherwise you will be going to save the data in slave IC. Okay, so based on that bit it will be working. Then fourth field, adu, that is 10th bit. Okay, defines whether the present data is an acknowledgement. So masterல இருந்து ஸ்லேவ்க்கு தான் it going to transfer the data. So slave have to give acknowledgement for it, for transferring the data from master. Okay, so accept பண்ணிருச்சாங்கிற ஒரு ஸ்டேட்டஸும் வேணும். Okay, that is provided in the 10th bit. Then 11th bit, fifth field is 8 bit field. So 11 to 18. Okay, so 11 to 18 bit is used for transferring the data information. What information you have to transfer, that will be stored in the frame from the place 11th to 18. Okay, then sixth field is 1 bit, that is 19th bit. Okay, so 19th bit is negative acknowledgement bit from the master. So negative acknowledgement means it will be providing the acknowledgement for the slave device that it had transferred the data. So if the 19th bit is active, that means it is 1, means acknowledgement after a transfer is not needed from the slave. Else acknowledgement is expected from the slave. ஸோ 19th பிட்டில் வந்து ஹையாக இருந்ததுன்னா ஸ்லேவ் வந்து அக்னாலேஜ்மெண்ட் மாஸ்டருக்கு தரணும். ஓகேவா, எப்போ ஆஃப்டர் ரிசீவிங் த பிட் ஃப்ரம் மாஸ்டர். ஓகே, ஐ ஹேட் ரிசீவ்டு த டேட்டா ஃப்ரம் யூ, லைக் தட் it has to give acknowledgement to the master device by sending high signal to the master. Okay, unless if it is 0, 19th bit is 0, master says you don't want to give any acknowledgement after transferring the data. Okay, that will be mentioned in the frame itself while sending the data. Okay, then 7th field, so 20th bit is stop bit. Okay, which will be used similar in the universal asynchronous receiver transmitter circuit. So that's all. So this is the 20 bit frame format will be used for transferring the data in the I2C bus. So what are the disadvantages of using this is given here. So the disadvantage of this bus is the time taken by algorithm in the master hardware that analyzes the bits through I2C in case the slave hardware does not provide for the hardware that support it. Um, uh, so the disadvantage means the time taken in the algorithm analyzing will be the one of the disadvantages, but some IC will be supporting the protocol and some will not support this protocol. Okay, this is the disadvantage. So in not supporting cases, interface circuit for those IC will be required. Okay, so in some circuit I mean in some device, IC device, it will be this protocol, IC square protocol will be accepted. Where I2C protocol not accepted, you will be using some interface circuit to communicate. Okay, also there are open collector driver as the master. So in the in the master device you will be using some extra additional circuit as driver, open collector drivers. Okay, to drive the circuit, to drive the circuit means to transfer the data. Okay, additional circuit is required. And then pull up resistance will be used in the additional drivers. Okay, so these are the things will be giving a disadvantage of using the I2C protocol, that is communication protocol. So I2C is a serial bus for interconnecting IC. It has a start bit and stop bit like UART. It has 7 field. Okay, 7 field means 20 bits. 7 field which will be having 20 bits. That is start bit, 7 bit address, and then 1 bit for read and write, and 1 bit for acknowledgement, and then data bits 8 bit, and then non acknowledgement as well as n bit. So all this 20 bit will be forming a data frame for the I2C serial bus. Okay.